Hello viewers, welcome to Physics Facilitator. So in today's session we are going to continue to learn motion chapter which we have started in our previous session, and already two parts of videos of this chapter have been uploaded in our channel. Please do check that two videos also. Okay, now let us begin our session. Average speed. Average speed ante enti? So why we are taking again average speed and average velocity? Already we have discussed speed and velocity, right? But malli enduku average velocity, average speed ostundi? Because we have two types of motion, right? Uniform motion and a non-uniform motion. So uniform motion case lo we can take only speed and velocity, whereas in non-uniform motion we require average speed and average velocity. For example, if we say a car is at point A and it is moving to point B, point C and point D. Okay, so let us say the distance of point A to B is 10 meters. Okay, this 10 meters the car is traveling in 2 seconds. Again, from B to C it is traveling another 12 meters in 4 seconds, and from C to D it is again traveling 15 meters in another 5 seconds. So, in this situation, are the distances same which the car is traveling, or the time intervals are same? No, right? So, the car is traveling with unequal distances and unequal time intervals. So, this is a non-uniform motion, right? So, if we calculate the speed of the car to reach from A to B, then what it will be? D by T, that is 10 by 2, that is 5 meter per second. So, the car speed is 5 meters per second in situation A to B. Next, let us see from B to C. Then, what it will be? 12 by 4 equal to 3 meter per second. Okay, so this is it in second case. Now, let us see the third case, that is C to D. 15 by 5 equal to 3 meters per second. So, what is happening here? The speed is varying. So, the speed is not constant. So, if you want to know in what speed the car has travelled in this total journey, is it possible with only speed formula or velocity formula? No, right? So, we need average speed and average velocity in order to know the average speed and average velocity of a non-uniform motion body, right? So, by this we can say that average speed is nothing but it is the total distance covered by time taken. Okay. టోటల్ డిస్టెన్స్ అంటే ఎంత వస్తుంది? ఇప్పుడు ఈ సిచ్యువేషన్ లోనే చూడండి ఎంత వస్తుంది? 10 ప్లస్ 12 ప్లస్ 15 divided by what is the time? 2 plus 4 plus 5. What you will get? 37 by 11. So we will get in points like 3.36 meter per seconds. Okay, so average speed of this car is 3.36 meter per seconds. Okay, in total journey. Okay, so this is the way we calculate the average speed in case of non-uniform motion. So, in case of uniform motion, do we require to calculate average speed? No, right? In every point, the speed of the car will be same. But in practical, is it possible? No, right? Mostly non-uniform motions only exist. Now, let us study average velocity. Average velocity is nothing but it is total displacement by time taken. Average speed units are also meter per seconds and the average velocity units are also meter per seconds. Okay, so this is average speed and average velocity. Now let us see few situations under non-uniform motion. Okay, observing the motion of a ball on a inclined plane. So what we are doing here, we have taken a inclined plane and we kept a ball on the top of the inclined plane, and let us push the ball towards down. Okay, now let us say the ball which is here is at time t equal to 0 seconds, and when it is moving, let us say in this position the time is 1 second, and in this position, that is when it reached downwards, the time is 2 seconds. Okay, so what you are observing in this situation, the speed of the ball is increasing whereas the direction is not changing, right? It is moving in one direction, but the speed of the ball is increasing when we are releasing a ball from top of a inclined plane. Okay, now let us push the ball from down to up on an inclined plane. Let us say this is at 0 seconds and this is at 1 second and this is at 2 seconds. Okay, so in this case what you will observe, the speed of the ball is different from the speed of the ball in first case, right? In this case the speed is fast, in this case it is somewhat slow. Okay, so the speed is different from first case. And is the direction of the ball is changing? No, right? The direction is not changing, it is constant, it is traveling in the same direction, whereas the speed is different from first case. Okay, so by this activity we can conclude that speed changes with direction remaining constant. Okay, so in this case we can say that speed changes with the direction remaining constant. In two situations the direction is constant but the speed is changing. In first case it is different and in second case it is different. Okay, next, observing uniform circular motion. So to understand this, let us do a small activity, like we have to take a stone and tie this stone to a rope. ఓకే, ఏం చేస్తున్నాం మనం ఇక్కడ, ఒక స్టోన్ తీసుకొని దాన్ని ఒక రోప్ కి టై చేస్తున్నాం. టై చేసిన తర్వాత ఆ స్టోన్ ని మనం రొటేట్ చేయాలి. రొటేట్ చేసినప్పుడు అది ఎలా తిరుగుతుంది? ఇట్ విల్ రొటేట్ ఇన్ అ సర్క్యులర్ పాత్, రైట్, ఇన్ దిస్ డైరెక్షన్, రైట్. సో if you draw the path of this rotating stone, what will be the path of this rotating stone? It will be circle. So this is the path. Let us assume speed is constant. So by seeing this circular path, we can easily say that the speed remains constant but its velocity changes. Okay, if you see in this instant, let us say this is A. Okay, in this instant the velocity is different. In this instant, let us say this is B. In this instant the velocity is different. So at every instant the velocity is changing but the speed is remaining constant. Okay, so for this we can take examples like windmills have blades, right, for rotating. So that motion of blades is an example of uniform circular motion. Okay, and also the artificial satellites around the earth, there are also examples of uniform circular motion. And also in our watch we have a seconds hand, right? So the tip of the seconds hand is also an example of uniform circular motion. So in these all examples we can observe that the speed is constant and velocity is changing. Okay, next, observing the motion of an object thrown into air. So for example, this is a ground and assume here there is a person. Okay, this A person have thrown a stone into the sky. So what will happen here? How will be the speed and in which direction the stone will fly and it will get down? So when the person is throwing from this point, the stone will travel in this way, right, in this way, and it will fall down here. Let us say this point is B. Okay, so actually what is happening here? When stone is flying in this direction, that is upward slope, it will have less speed, right? When it will reach to this point, that is downward slope, when it is traveling in downward slope, it will have high speed. And another point here is the direction of motion of stone is changing, right? First it is traveling like this, again it is traveling in this way, again it is coming in this way. So the direction is changing as well as the speed of the stone is also changing, right? In upward slope it is somewhat slow compared to the speed when it is in downward slope. So what is happening in this situation? Both direction and speed changes simultaneously, that is both are changing at a time. So till now we have done 3 activities, right? So in each activity we have learned a point, right? So in first activity, that is pushing a ball from an inclined plane from up to down and again pushing the same ball from down to up. In that case, we have observed that speed changes. Speed changes but direction remains same, right? In second case, that is rotating a stone. In that case, what we have observed? We have observed that direction of motion changes but speed remains constant. Right. And in third situation, that is throwing a stone into the air. In that situation, what we have observed? Both speed and direction changes simultaneously, right? So we have learned 3 points from these 3 activities. So that's all for today's session. Let us meet in another amazing session. Please like, share and subscribe to my channel and please support my channel.